This is the rule for adding and subtracting binomial radical expressions. The indices, that's the index, and the radicand, that's the number underneath the radical symbol. If they are the same, if the index and the radicand, if they're the same, it's just like combining like terms. You just add the coefficients or subtract the coefficients. It's exactly the same idea of combining like terms. If the index and the radicand are the same, then they're considered to be like terms. Add the coefficients. So in this first example, we have two terms. We have the red term and the blue term. Do both of these terms have the same index? Do they have the same radicand? Then you just add the coefficients. So Brian, what's the answer? 12. 12 square root of 6 is the answer. You must understand this rule. The index has to be the same. The radicand, the number underneath the radical, has to be the same. If they are, just add the coefficients. The answer is 12 radical 6. Next example. What's the answer? What is the answer? Exactly. Anthony said we can't combine them. Can you explain why? Absolutely. Did everyone hear that? We cannot combine these two. They don't have the same index. Straightforward, yes? Next example. Antonino. Negative 2 rad x is the answer. Any questions? Next example. At first glance. At first glance. At first glance. Before we automatically say we can't combine them, because you'd be correct. The radicands are not the same, right? But everyone needs to take notes here. But can we simplify them? If we can simplify, we have to simplify, and that might change everything. So how would we simplify this one here, the red one? This would become 6 times, use a smaller. This is 6 times radical 9 times radical 2. Is anyone confused about what I did here? And if we continue to simplify, this is 6 times 3 times radical 2. This is 18 radical 2. Any questions about this red one? Anthony, the blue one. Yes, just let me catch up with you. Can you just walk the class through how you got that? Thank you. And continue. I'll write while you talk. Okay, and final is? Thank you. So at first glance, the radicands were not the same, so we thought we couldn't combine them. But if we can simplify, we must simplify. After simplifying, are the radicands the same? The index is the same. So we can combine them. So what's the answer? 33 radical 2 is the answer. Any questions? Next example. Now we're going to multiply. Multiply. Multiply and simplify. Again, this is all stuff you know how to do. It looks foreign, but do not be dismayed. It's not that bad. It's not bad at all. It's actually delightful. Antonino.
Supposed to distribute.
Distribute. So you want to walk us through it?
Okay, 5 times 7 is 35.
Okay.
5 times 4.
Yeah.
Rad 5 is 20. Rad 5.
Thank you. Positive, right?
Yes.
All right, before you continue, does everyone understand what we're doing here? It's just FOIL, right? All right, go ahead, Antonino.
Plus 14. Rad 5.
Okay. Let's get some of this right here. All right. All right, go ahead.
That would be plus 8. Radical 25.
Nice job. Any questions before we continue? Nope. All right, now we have to simplify. Angelina. Yeah. What did you say? Okay. All right, so it's 8 times 5, right? Which is 40. So this is all positive 40. That purple term is positive 40. Does that make sense? Because I'm going to erase some stuff because there's a lot going on here. I'm just going to write positive 40. Did everyone write that down? All right, so this is positive 40.
28 radical 5 plus 14 radical 5 plus 34 radical 5.
Say that again?
28
Mm-hmm.
radical 5 plus 14 radical 5 is 34 radical 5.
Thank you. 34 radical 5. So this is 35. We'll combine these two. Right. These are like terms. So this is 34. Positive 34 radical 5. And we have this 40 radical 5 there. Are there any more terms we can combine in? And we get 75. So our final answer is 75 plus 34 radical 5 after we combine these two like terms there. And that's it. We cannot simplify any further. This wasn't hard, was it? Not bad. Next example. All right. So this is a concept I need everyone to understand right now. Whenever we are squaring anything, most of you probably know this, but there's always a couple who don't get this idea. If I say x squared, correct? That's the same as x times x. Does that make sense? Yeah? All right. So most of the time when say we have x plus 4 squared, not everyone, but some students see this and they think this is the same as x squared plus 4 squared. Did anyone in here think that that's the case here? All right, so how do we expand this? How should we expand this? Exactly. So radical 3 plus radical 5 is radical 3 squared. Radical 5 times radical 3 plus radical 5. So when you square anything, it's that thing multiplied by itself again. So don't distribute this 2 to both of those and think that's what you need to do. You have to take that binomial and rewrite it, multiply it again. And from here, we simply do the same thing we did on the last slide. All right, so let's do it now. You already know your classwork, so if I'm starting to put you to sleep, you can get started if you want, but I'm going to continue with this example here. Radical 3 times radical 3 is radical 9. Eventually, you'll start to realize that it's just 3, right? But I'll write radical 9 and we'll simplify it later. This is going to be radical 15. plus radical 15 plus 5 or radical 25. We'll simplify afterwards. Now we have 3. What happens here? What is this here? When I combine these two? Now radical 30. What's the rule? Remember the rule? Radical 15 plus radical 15, what is that? 2 radical 15. Can you explain why? Exactly. There's a 1 here and a 1 there. The rule we learned at the beginning of class, if the indices are the same and the radicands are the same, which they are, just add the coefficients. So it's 1 plus 1, which is 2. Radical 15 plus 5. And our answer is 8 plus 2 radical 15. I'm going to stop here. There's one more thing, but I think everyone has had enough, right? Yeah? All right. So the last thing is conjugates. We'll talk about this tomorrow. If you see any questions on the assignment about conjugates, you can skip those.